All right. So we've got potassium is added to aqueous boron oxide. So we got some potassium, just like that, all by itself. So we don't need to worry about a charge just yet. We got boron, which looks like that. Oxide, 2 minus, which means I need 2 borons, 3 oxygens. So potassium plus B2O3. Now, just a disclaimer here. Boron is not a true metal per se, but it kind of behaves like a metal in this case. So we'll just pretend it's a metal and a +3. And it kind of says that on your periodic table anyways. You guys may or may not have noticed that, but I at least wanted to have a little clarifying statement for you. All right, this to me looks like an A plus BC single replacement type of reaction. And again, if you guys are struggling recognizing the type of reaction, I really encourage you guys to go back to those notes that we took a little while ago. It's just recognizing a pattern in our reactants to predict the products. Okay? So, I've identified the reaction type. Now I need to predict my products. So, metal replace a metal-like substance. So, hydrogen and boron are both often behave like a positive ion in our formula. So, we'll just pretend it's a metal. So, potassium is going to replace oxygen. Now, potassium is just a +1, which means when it combines with oxygen and replaces the boron, the 2 from oxygen needs to go to the potassium, so it's K2, and then just 1 oxygen, because potassium is +1. So again, notice I'm not just taking this subscript that's there and bringing it over. We don't do that, right? We write the formula for the product based on the charges. Potassium is a +1, oxygen is a -2, which means I need 2 potassiums to neutralize 1 oxygen, and then boron is going to be left all by itself there. Okay, so that's our single replacement reaction. We predicted our products, and then of course wrote the correct formulas for those products. The last thing to do is to balance this bad boy, right? So we do that by identifying how many we have of everything on each side. All right, we got 1 potassium, 2 borons, 3 oxygens. Over here we got 2 potassiums, 1 boron, 1 oxygen. All right, so let's start with our potassium. Why not? Let's put a 2 there. Now, I got 2 borons here. Well, how about I put a 2 there? That makes that nice and neat, but my oxygens are way off here. Got 3 oxygens here. Right, which means I'm going to have to put a 3 there, which makes that a 3, but it also makes my potassiums 6, right, which means I'm going to have to erase this 2 right here. Oops, excuse me, I don't have 6 over there. The way that's written, let's backtrack. The way that was written was I had a 2 there, right, so that's still 2, and my potassiums over here are 6. Sorry, I did not want to confuse you the way it's written previously. But yes, I am going to have to erase this potassium coefficient there. I need it to be 6. So rather than being a 2, we make that a 6. Now it's a 6. Sorry about the boo-boo.